Okay, welcome to Ms. Nichols' YouTube channel. I am starting with the medium equations right now in our balancing equations challenge, and we are on problem number 19. So problem number 19 is a problem that's sometimes difficult for students, so I'm going to go through it. First thing we do, as always, is count by setting our atoms or ions equal to subscripts. So this has a subscript of 2, N is 2. H has a subscript of 2. Then I go to the other side, and my formula NH3 has 1 N and 3 H's. I always start at the top of the list and compare how much I have. I have 2 N's on the reactant side, 1 on the product side, so I need to increase the amount that I have on the product side. I'm going to do that by putting a coefficient in front of the formula that has that atom in it. So I'm going to put a coefficient of 2 here. That is going to multiply this by 2, but it is also going to multiply the H by 2. So I'm going to end up with 2 and 6. All right, so now my nitrogen is balanced, but my hydrogen is not. I'm going to go back over to the other side and put a subscript of 3 in front of hydrogen right here. All right, so that's going to multiply this hydrogen by 3. I'm going to end up with a total of 6, and that equation is balanced. All right, now we're going to do number 22. Number 22, I just want you to notice that the lists are not in the same order on the reactant and product side, but that we should still be able to balance it just fine. All right, so we've got copper is equal to 1. Shh. I'm making a video here. Copper is equal to 1. Sulfate, there is no subscript outside of the parentheses. So I'm looking right here. Nothing there means it's equal to 1. Aluminum is a single, so that's equal to 1. On the other side, aluminum is equal to 2. Sulfate has a subscript of 3 on the outside. And copper has no subscript, so that's a 1. Now, when I compare, I want to be mindful of the fact that the lists are not in the same order. So I have copper here and copper here. They are balanced. Sulfate is 1 here and 3 over here. So I'm going to put a 3 in my coefficient blank on this side to increase the amount of sulfate. That's going right here. It's going to multiply SO4 by 3. And it's going to multiply the copper by 3. All right, so now I compare again. Since I increased the amount of copper, I'm going to have to fix that on the other side of the equation. And so I'm going to put a 3 in the blank over here to increase the amount of copper. That's times 3 here. And I'm going to go across my list here and compare everything. Copper is balanced, sulfate is balanced, aluminum is not, but that's easy to fix because aluminum's by itself over here. So I'm going to put a 2 right here. That's going to multiply aluminum, and now that is balanced. All right, we're still on the medium hard equations. I'm going on to number 23. Number 23, we have an OH on one side of the equation and water on the other. When we see that, we've got an acid-base neutralization, and that is our signal to rewrite water. This is H2O, but I'm rewriting it like this, H and OH. Now I'm just going to go ahead and balance it as normal, but now I've got the same list on both sides, the reactants and the products. I'm going to count by setting equal to subscripts. No subscript is 1, so H is equal to 1. Cl is equal to 1. Na is equal to 1. And OH Remember, I'm looking out here, there's nothing, it's equal to 1. On the other side, H now is right here. Has no subscript, it's a 1. OH is a 1. Cl is a 1, and so is Na. So this equation is balanced just as it is. I do not need to do anything else to it. I don't usually write this, but I'm just going to put this in to make that clear. Okay, now the one after that is something we call a double replacement. We've got two compounds where the different parts of the compounds are switching places. All right, so our lists are a little mixed up again too, because you notice I have OH here and Cl here, and then Cl here and OH here. I try to keep them in the same order, but I made a few mistakes on this worksheet. So just always make sure you know what you're looking at. So I'm going to put 1 for Ca. I'm looking here for the OH. That is equal to 2. Fe is equal to 1. And Cl is equal to 3. On this side, Ca is 1. Cl is 2. Fe is 1. And OH is 3. I compare. My calcium is the same on both sides. I look here and here for OH. Now this is a tricky one. It's hard to see how I can make these the same unless I look for a common multiple. So common multiple means what is something that both of them divide into, right? And that is the number 6. So I'm going to try to get them both equal to 6. I start out on this side, and I start out on the reactant side, and I'm going to multiply OH by 3. All right, but a way I multiply is I always put the coefficient in the blank. All right, you don't want to just go and multiply, because then you will forget to put the coefficient into the equation. Once I do that, that coefficient will multiply the OH and the calcium. All right, so that's taken care of. It doesn't really seem like I've fixed anything, but I'm remembering that I'm trying to get both sides, the OH, to 6. So I'm going to go to the other side and put a 2 here. That 2 is going to multiply the Fe and the OH. And now, at least my OHs are balanced. It doesn't seem like anything else is, but that will happen. All right, so my OHs are balanced. I'm checking that off. Then I look at my calcium. I've got 3 here and 1 here. So I'm going to multiply on this side where I have less. I do that by putting a coefficient in the blank. The coefficient will multiply everything in the formula. So that's going to be 1 times 3 and 2 times 3. All right, I look at my list again. Now my calciums are balanced. Cl is not. Well, wait, Cl is. So I've got 3 here and 3 here. So that is balanced. Oh no, this should have been a 6. Sorry about that. My mistake. So it's not balanced. I know, it's crazy. All right, so not balanced. I've got a 6 for this Cl and a 6 for this Cl. So I need to increase over here. I'm going to put a 2 in this blank. It's going to multiply here and here. And it's magic. The equation works out, right? So now I've got a 2 here, 2 here, 6 here, 6 here. So even though my list was out of order, it still worked. Even though it was crazy and I had to go back and forth a whole bunch of times, you can always make it work. Because I don't give you equations unless you can balance them. All right, smiley face, and that is the end.